Welcome to Friday, everyone. Woohoo! All right, here is our next topic, next example. This is a situation that I call apparent weight. Other textbooks just talk about forces in vertical systems or vertical situations. When we think of weight, we're thinking of how heavy something is, the force of gravity. But there are situations that we can come across where something feels heavier than what it actually is, or it can feel lighter than what it actually is. So, for example, if you've ever been on a trampoline and you jump fairly high, there's a moment in the air where you don't really feel any weight on your body. You feel kind of weightless. Your body feels kind of floating in the air, and if you especially have long hair, you can kind of see your hair floats around you. So there are situations where it appears that your weight is different than what it actually is, even here near Earth's surface. So here's a basic question, basic example to try to highlight how this works. Okay, so it says at school I lift my 1.5 kilogram textbook, and when doing so I accelerate it upward at 2.5 meters per second squared. So there's a moment where you grab hold of the textbook and you pull up. And in order for you to start moving it upwards, you have to be stronger than what gravity is. If you are exactly the same strength as gravity, that means that you just have exactly balanced it out, and the textbook doesn't start moving yet. It needs to accelerate upwards. So you're pulling it fairly strong so that it's going to accelerate upwards. Maybe that doesn't last for very long, but there's a period of time where you accelerate it upwards. And the question is, what is the apparent weight of the textbook? In other words, how heavy does it feel when I accelerate the textbook upward? So, like other times, we're going to start off with a free body diagram. Here's my textbook, and I want to draw the two forces that are acting on this textbook. One of them is going to be the force of gravity, so that's this one here, and I'll label that. Excuse me. Force of gravity. And then I also have the normal force, or the applied force maybe in this case, not a normal force, an applied force going upwards. But what I hope you can recognize already is that this force must be bigger than the force of gravity. The question tells me that I am accelerating it upwards, or the object is accelerating upwards. So if there's an acceleration, then that means that the forces are not balanced. And if it's accelerating upwards, then that means that the upward force must be larger than the downward force. So this is my free body diagram right now. And the question is asking me, how heavy does it feel? What is the apparent weight? What it's really then saying is, what is the value of this force that I am pulling with? What does it feel like to lift this book at this acceleration? And I recognize here that in my text I don't have kilograms behind the behind the 1.5. So let me just quickly see if I can change that. kg. There we go. So the whole situation here is I want to find what is the value of this force. This is the force that I am pulling, so that's the force that I feel when I am pulling. That's how heavy it feels to me. This is the actual weight, Fg, but this is the force value that I am looking for. All right. So we need to do some equation work out of this. Alright, so at this point what I've got are the two different ways that we can calculate Fnet. Fnet equals mass times acceleration, and Fnet is all the forces combined, F1 plus F2. In this case, I can already create this equation for my situation because these are the two forces and I know that they don't cancel each other out. So before I move on, I am already going to create this particular equation. where I know that the forces that are involved are going to be FA and FG. The only thing here that I'm going to change, however, is the fact that I recognize that these two forces are in opposite directions. So that really means that one of them needs to be a positive and one of them needs to be a negative. Most of you prefer that up is positive and down is negative. So what I'm going to do in this equation is I am going to change that this for the FG is going to be negative. I can recognize already that it's going to be a value that goes down. Oh, my thing is pausing here on me. Let me try this again. There we go. Alright, so now hopefully what you can recognize is that if this is the value that I want to find out in the problem, I'm going to need to figure out these two values here. So here is another thing that I'm going to have to find, but I happen to know what that equation is. So here I've got Fg equals mg. Well, this is connected here, this is connected here. To find F net, I need mass and acceleration. I've got mass, I've got acceleration. To find Fg, I need mass, which I've got, and I need gravity, which I know is a value of 9.8 here on Earth's surface. So I can figure out these values. Oops, try that again. So we're going to try to figure this one out. We have a mass of 1.5 and an acceleration of 2.5. And then when we calculate that out, we get 3.75 newtons. Good. So that's the net force. That's really saying that this force here is 3.75 newtons more than this one. That's really what this is saying. Well, let's figure out the value for Fg now. Copy, paste, put that in here. We can edit. Our mass again is 1.5. and our gravity is 9.8. And I got a value of 14.7 when I calculate that out. .7 newtons. Good. So now I can place those values into my equation. Copy, paste. Alright, so our Fg was a value of 14.7, and our F net was a value of 3.75. And so now I just have to algebraically figure out what this value is, and hopefully you can see that I'm going to add 14.7 over to the other side. Excuse me. So FA is going to equal 3.75 plus 14.7, and I'll get 18.45. Well, let's round that to 18.5 newtons. There we go. And that becomes my answer right here. 18.7 or 18.5 newtons. So in this particular question, this is the actual weight of the textbook, 14.7 newtons. That's Fg. But when I accelerate it upwards at 2.5 meters per second squared, it feels like it has a weight of 18.5 newtons. So that's what apparent weight situations talk about. Hope you can take a look at this particular problem, go through it, and I will also have an assignment up on the website. Okay, thank you. Talk to you guys soon.